Good evening everyone. Good evening. Hello PK, hello Surendra, hello Pranshu. So welcome back to the official YouTube channel of Origin Coaching. First of all, let me know in the chat box if it is I am audible and visible to all of you. Let me know in the chat box if I am audible and visible to all of you. Good evening Satvik, hello Ravi, hello Shivansh. Ravi, stop spamming in the chat box, okay? Stop spamming in the chat box. Hello Love Kush, hello Deepak, hello Ram. Good evening Sonu. Hello Shubham, hello Mahif, hello Sachin, hi Saurabh. Okay. So today we are going to continue our second chapter from our NCERT textbook, which is the structure of atom, and in our today's session we are going to discuss about something known as Planck's quantum theory. Okay. Today we will be discussing about something known as Planck's quantum theory, and this is our lecture number from 4th from our chapter 2. Okay. So for the ones who are new to this channel, let me tell you to like this session, subscribe to this channel and press the bell icon so that none of the video is missed by you, which will be taking in this channel live. And last but not the least, share this channel with your friends so that every single student who want this kind of knowledge will be benefited from our channel. Okay. So what we are going to discuss in our today's session? In our today's session we are going to cover the Planck's quantum theory, which leads to the calculation of energy of any orbital we can say electromagnetic radiation. And before that we will discuss something known as electromagnetic radiation, why it occurs and how it occurs, what is the reason behind the electromagnetic radiation, and what are the kinds of objects that emit electromagnetic radiation. So let me know in the chat box if you all are excited for today's session. Okay, you can let me know in the chat box if you all are excited for today's session. Clear? Okay. Ready all of you? So let us continue our today's session with our topic something known as Planck's quantum theory. But before that, okay, let me know in the chat box any type of radiation you know, I have told you about something known as electromagnetic radiation, properties of waves, and I have also explained you the examples of electromagnetic radiation. So I want to know if you remember what were the examples of electromagnetic radiation which we have discussed in our previous lecture. Anyone who knows example of any example you know from electromagnetic radiation, or just leave that word electromagnetic, any example of radiation you know, you can let me know in the chat box. Any kind of example of electromagnetic radiation, you can let me know in the chat box. Okay. Anyone? Example of electromagnetic radiation. Hello Ashish. Okay, thank you Music Home. Sun rays, yes, sun rays is a correct example. Prince, okay, sun ray we can say, but actually those are UV rays. So sun ray, it is not sun ray, those are UV rays. Okay, so UV rays is an example of electromagnetic radiation, but the most visible is example of electromagnetic radiation is visible rays. Okay, visible rays, yes Supriya, UV rays. So here I am taking the list of visible rays which we can see from our naked eyes, okay, which is V, I, B, G, Y, O and R. Clear? These are the sort of visible rays which are known to us, and its full form was violet, indigo, blue, green, yellow, orange, red. Vigor, clear? So now, here in this list of visible radiations, okay, in the list of visible radiation, let me tell you one thing, that from violet to red, the energy decreases, okay. On going from violet to red, the energy of the visible radiation decreases, but from going from violet to red, the wavelength, okay, the wavelength increases. And now the word UV rays, okay, we were discussing about UV rays. So UV rays having more energy than violet are known as UV rays. And infrared rays, after red we see infrared radiation, clear? So these are the list which we'll be discussing about in our electromagnetic radiation. So now, first of all, let me tell you why any body emits radiation, okay. First of all, I'll be telling you why any body emits radiation. So the reason behind the emitting of radiation from any body is, here I am taking, okay, I can say these are the orbitals of any atom, and here there is an electron, okay, this is an electron I am supposing. And when this electron goes from this orbit to this orbit, okay, when this electron goes from this orbit to this orbit, then it reserves energy inside itself. But the reason is, why will this electron move from this orbit to this orbit? The reason is, we will provide energy to the electron, okay, we will provide energy to the electron. And when we will provide energy to this electron will absorb the energy we are providing it, and it gets excited, okay, it gets excited, and that's why he leaves his original orbit and goes to some upper level of orbits, okay, orbits having more energy. I'll be telling you in some time what kind of energy any orbit have. But the fact is, whenever any electron will go from lower level of orbit to higher energy level orbit, it will absorb energy. And now here comes the concept of electromagnetic radiation. When the electron which goes here, when this electron again comes from this orbit to this orbit, okay, it emits radiation. This is why any electron emits radiation, okay. Whenever an electron gets excited and tries to come back to its original orbit, then while coming from the excited state to the original state, or we can say ground state, that electron emits radiation, okay. That is why any electron is supposed to emit radiation, okay. And now, so this is the theory that why any particle emits radiation, okay. This is the theory behind why any particle emits radiation. But now, what type of particles emit radiation, okay, what kind of particles emit radiation? So this is where we have to discuss about something known as Planck's quantum theory, okay. In the Planck's quantum theory, we'll be getting know about two things, okay. We'll get to know about two things. What are those two things? First thing is, what type of particles emit radiation, and the second thing will be, what is the energy emitted by any particle while emitting electromagnetic radiation, okay. What is the energy released by the particle while emitting electromagnetic radiation? So while I was telling you about the visible radiation, we have seen that energy of every radiation is different. Yes, energy of every radiation is different. So that's where we have to calculate the energy of radiations. But before that, what are the particles who emit radiation. Okay, what are those particles which emit radiation? So in the Planck's quantum theory, Planck told us that every particle in nature emit radiation. Okay, this is what a very different thing Planck told us, that every particle in the nature emits radiation. Even me, I am emitting radiation, this pen is emitting radiation, this board is emitting radiation, which is visible radiation. Every particle in the whole universe, okay, every particle in the whole universe emits radiation. So this is what Planck told us in its first postulate. This is what the first postulate of Planck's theory tries to tell us, that any particle in the nature emits radiation. Okay, and now the second thing which comes to us is that yes, every particle in the nature emits radiation, and we also know that every particle is made up of atom. Yes, every particle is made up of atom, we know this thing also. So here, from these two statements, can I say that atom leads to radiation? Okay, or we can say atom emits radiation. So any particle which is made up of atom emits radiation. Clear? This is the main thing which Planck told us, and this was a very different thing. The people of that time didn't believe that every particle emits radiation, but now we have discussed those theories, that why we can believe that every particle emits radiation. And now from these two statements, I can say that atom leads to the emission of radiation. Okay, atoms leads to the emission of radiation. And now what's the second thing which comes to us after this? After this, Planck told us very important thing. Here I am taking a particle. For example, this is a particle which is emitting radiation. So I have told you that these particles emit radiation in form of waves. Yes, I have told you that any particle emits radiation in form of wave, and that's what the definition of electromagnetic radiation. Electromagnetic radiation is a form of energy which travels or propagates in the form of waves. But Planck told us that any particle which emits radiation does not emit radiation in form of continuous waves. Okay, it does not emit radiation continuously. Instead of this, it radiates, it emits radiation in form of small packets. Okay, like this. Okay, any particle emits radiation in form of small packets like this. So it is not continuous. The emission of radiation takes place discontinuously. Okay, the emission of radiation takes place discontinuously. So this is very important thing which Planck told us in his theory. Okay, so this is an important point that you have to take a note of, that any particle does not emit radiation in continuous form, it emits radiation in discontinuous form or in form of small packets. And what did he give the name to these packets? He named these packets as quanta. Okay, he named these packets as quanta, and this is what we known as quanta. This single packet is known as quanta, and when we will be talking in terms of light, when we will be talking about light radiation or visible radiation, these packets are known as photon. Okay, in terms of light radiation, these terms, these packets are known as photon. So let me know in the chat box if there is any doubt left with you related to this theory, and then we will calculate the energy. We will calculate the energy emitted by the, or electromagnetic radiation emitted by the particle. Piyush Saraswat, that class takes place from 7 to 9, okay, 7 to 9. Satvik, you can just drag the video little back. I have told why this takes place, okay. I have told you why this takes place. You can just drag the video little back, okay. It takes place just because we provide energy to the electron, it gets excited, and when he tries to come back to its own original orbit, it emits radiation, okay. It emits radiation, and while it emits radiation in form of small packets. So this was something important which Planck told us, and now this is just a theory. After then he gave us a definition, or word to word we can see this here. What Planck told us: the radiant energy which is emitted or absorbed by the black body is not continuous but discontinuous in the form of small discrete packets of energy. Each such packet of energy is called quantum or quanta. In case of light, the quantum of energy is called a photon. Clear? It is called photon. Okay, Satvik, your question is that why it is not continuous. Okay, there's an explanation for that also. Let me suppose you that if anyone slaps you and just slaps like this and continuously pushes your face backward, then you will feel more power, or when he slaps you continuously and then he pushes you towards the ground. Okay, for example, here let me tell you, I'll be explaining you with a figure. Here something is there, and now I am pushing it towards back, pushing it towards back, and when I'll be just applying one time pressure, and then I am continuously pushing it towards back. Okay, and in the second case, I am continuously pushing it. I am continuously applying force into it. And then in which case will this wall experience more pressure? When I'll just press it, for example, here it is my hand, I am pressing it and continuously I am sending it towards the back, and in the second case I am just like this. I am in small intervals I am pressing it, in which case this hand will experience more pressure. And that's how we know that the electromagnetic radiation takes place in the form of intervals. Okay, because since electromagnetic radiation has energy and it is continuously getting energy in the form of small packets, here that we know that's why we know that the electromagnetic radiation takes place in form of discrete packets. If the electromagnetic radiation will take place continuously, then there will not be that much energy which is required for a electron to get back towards its original orbit. And here we will calculate the energy. In our today's lecture we will calculate energy, so that this concept will be more easier for you. Clear? Okay, so this is what the definition of Planck's quantum theory tells us. The energy of each quantum is directly proportional to the frequency of the radiation. Okay, here we will calculate the energy of a quanta, or quantum we can say. We will calculate energy of a quanta, that what amount of energy any quanta has inside it. So according to Planck, energy of each quantum is directly proportional to the frequency. Okay, energy of each quantum is directly proportional to the frequency. And now instead of this directly proportional, we multiply it by Planck's constant. Okay, we multiply it by Planck's constant. I'll be letting you know in some time what Planck's constant is, okay? And now, since Planck told us that any quantum is directly proportional to the frequency, okay? Any quantum is directly proportional to the frequency, and we know that frequency is equals to c upon lambda. Yes, frequency is equals to c upon lambda. So can I write it like this? E is equals to h into c upon lambda. Yes, I can write it like this, and this is how we can calculate energy, where h is Planck's constant, okay? And its value is 6.62 into 10 to the power 31, okay? Planck constant, and its value is 6.62 into 10 to the power 31, and this is how we can calculate, the energy of any particle, okay? This is how we can calculate energy of any particle. Oh, I wrote it 31, it will be minus 34, okay? 6.6 into 62 into 10 to the power minus 34 is the value of Planck's constant, and while putting the value we can get the energy of any quantum, okay? This is the process using which we can get the energy of any quantum. And now another thing, one more thing here we have to see in this session related to this topic, that is how can we calculate the number of photons, okay? We have to see how can we calculate the number of photons. So before that, you can let me know in the chat box if there is any doubt left with you. You can let me know in the chat box if there is any doubt left with you regarding this calculation of energy of any quantum. Clear? Is it clear to everyone? Let me know in the chat box. Babu, you will be getting Hindi medium lectures at 7 p.m. and 8 p.m. Okay? You will be getting Hindi medium lectures at 7 p.m. and 8 p.m. for 11th and 12th classes respectively. Clear? And now I will be letting you know how can we calculate number of photons. So for the calculation of number of quantum or photon, okay, for the calculation of number of quantum or photon, there is a formula, okay, there is a formula, number of quantum is equals to energy multiplied by lambda divided by h into c. This is how you can calculate the number of photons or quantum. This is how you can calculate what amount of photons you can any electromagnetic radiation can emit, and that is how we got to know that electromagnetic radiation takes place in form of discrete packets. Clear? This is how we got to know that electromagnetic radiation does not takes place continuously, it takes place in the form of small discrete packets. Clear? So you can let me know in the chat box if there is any doubt left with you. Simply, if we have to calculate the energy of 1 mole photon, okay, if we have to calculate the energy of 1 mole photon, it will be simply equals to lambda multiplied by what? Multiplied by Avogadro's number, which is 6.022 into 10 to the power 23, and this is how we can calculate the energy of 1 mole of photon. Okay, this is the formula for calculation of energy of 1 mole of photon. Clear? And there is one more thing related to this Planck's quantum theory, that is the total amount of energy emitted or absorbed by a body will be some whole number quanta. Hence, E is equals to n into h nu, where n is an integer. So what does this statement means? this statement means that if I am having n numbers of quanta, then energy of n numbers of quanta will be n multiplied by energy of one quanta. Okay, n multiplied by energy of one quanta or quantum. Okay, what it will be? I have to just calculate the energy of one quantum and I have to multiply it by the total number of quantum I am having, and that is how I can calculate the energy of the total number of quantums I am having. This is the process using which you can calculate the total number total energy present in the n number of quanta we are having. Clear? So this was something known as Planck's quantum theory, and this was just a basic concept. After that we will be discussing about something known as hydrogen spectrum, photoelectric effect. So this is just starting of our chapter, but many interesting things are still left. Many interesting things are still left in this chapter. Any doubt? Is it clear to everyone? Let me know in the chat box if it is clear to everyone, or you can write it in the chat box if you are left with any doubt regarding to this topic. And do one thing, just note down this statement. Very important statement it is, and that one derivation of the formula which I have told you, you can just copy that. Okay. Clear? So that was it for today. And once again I'll be telling you that like this session. If it proved to be useful for you, subscribe to this channel and share with your friends so that everybody gets benefits from our channel, which is our main motto. Okay. So now that was it for today. Nice meeting you all, and after the session ends you can just comment your doubts in the comment box. I'll try to reply each of the comment or question which you will be asking in the chat box. Otherwise, if the questions are very important, I'll be taking them in my next session. So now that was it for today. We'll meet in the next session. Till then, thank you. Good night.